Welcome to the data engineering project series. Today in this video, we will review uh, the foundational concept of data engineering. Okay, so what is data engineering basically? Okay, so and then we'll go to data engineering stages and then the third data engineering life cycle. So, what is data engineering? Data engineering is nothing but designing, developing, and maintaining a system that takes raw data, then produces high quality data in a structured manner, which is optimized for storage, securely maintained, and tracked continuously, and served to analytics and reporting platform in a timely manner to build insights for better decision making. Okay, so basically, what you have raw data that is coming from different sources, different digital products already in the market. Okay, different systems. It's in raw format. Now you have to convert that raw data into a high quality data in a very structured analytical format. Okay, and of course, it is has to be optimized for storage. Okay, we can cut down the cost of storage and we can manage the data. Then we have to ensure security and also we have to track the data continuously. So we can track the changes that are happening in the data. Okay. And finally, that data is served to the analytics and reporting platform in the timely manner so that insights could be built, derived from that data for better decision making of the business. So, in short, data engineering is engineering that support decision making tools and products of the organization. Okay. So, what is source of raw data? Okay. So, the source of raw data you can see in this slide. There are different sources. Okay. When you are doing a transaction to an ATM machine, you're buying some products. Okay, the point of sales, then make you are making an online payment, or maybe some medical sensors that is attached to a patient. Okay, then IoT, Internet of Things, you can control home appliances, electrical appliances, digital products. Okay, so this is all the source of raw data. They produces raw data. Now the raw data that arrives, okay, that is generated, it's not typically in a structured, organized manner. Okay, it is not good from the perspective of analytics. Okay, it is not in an analytical platform so that we can make some sense. We can perform some calculations. Okay, derive some insights. Okay, so you can see on this slide the raw data arrives in diverse different formats. It could be binary file, it could be a CSV file, it could be a JSON file, it could be XML, it could be logs. Again, if possible, it may even arrive in a structured, already in a structured format. It could be images, it could be videos, right? And then you need a storage. Of course, when a data is generated, there has to be some kind of storage to store that data. Maybe it is an external located storage or maybe within your project. Okay, so this is the raw data that is generated. Then we have to ingest that data. Okay, we have to ingest that data from external source to our system. And of course, when you ingest the data, you need a staging location, a staging area where you can stage the data. Okay, so that you can accumulate a certain amount of data. Okay, and that you can process uh, through the project. Okay, so staging plays a vital role where you can stage the data, you can temporarily store it. Okay, you can and then once the storage, a good amount of accumulated data is available in staging area, then you can proceed with the what we can say ETL or data engineering project. Again, also here we need the staging part. Okay. So also here we need a storage part. Storage is mandatory in the entire data engineering project. Storage plays a vital role. Without storage, the data cannot be retained. Okay. So in order to retain the data, we need the storage part. Then comes the transformation. Again, now whatever data, as I said, it's in raw format. It's not good for from the analytical perspective, right? It could be in different format, as I said. Now you can see on the left side there is some kind of a project report. Okay. Now that project report you have to go, you read, okay. But in order to make some sense, we have converted this data into an analytical tabular format. Okay, giving proper attributes, naming the attributes. Okay, to each and then once the data is attributed, it has an attribute, so it makes sense. So we can understand the data. Okay, so what exactly data is, what data wants to tell us, what information it is providing. Okay, from that information we can make some sense, we can make some calculations, we can derive, come to a conclusion. Okay, what the information is trying to tell us, and based on that we can make decisions. Okay, for the future. Okay, so this is converted, raw data converted into a tabular format or a structured organized data. Okay, so here there could many things can happen. Here you are applying, here you may apply the schema to the records. You can clean the data, improve the quality, remove the bad records. Okay, you can perform some exploratory data analysis. You can then perform some kind of aggregations, uh, many things. Okay, you may create pivots, right? So this is the transformation phase of the data. And again, as I mentioned, storage is required. So storage is going to be the common part in the entire data engineering project. Okay. Moving ahead, then the loading part. Okay. The loading part, once the raw data is transformed, is structured, its quality is improved. Okay. Then finally, that data is loaded into various reporting platforms, or loaded into data marts or data warehouses, where then these data warehouses, data lakes, the data marts are then connected to the reporting and the analytical tools. Okay, and from there they can create some data visualizations, build some reports. Okay, for the business teams. So this is the loading part. Okay, so extraction, then ingestion, then uh, transformation, and the loading part. So this is the basic idea of the uh, project. Okay, so we make the data go through different stages. Okay, to get the quality output for the better decision making. This is the overall life cycle of data engineering project. Now you can see the data was generated from digital products, digital devices, right? Then we made the data go through different stages: ingestion, transformation, serving. And as I mentioned previously, that storage is a common part in the entire data project, because we need to retain or store the data in order to do several manipulation changes in the data. And finally, when the data is ready to be served, it is consumed by various departments, also various requirements like analytical for machine learning to perform some uh, reverse ETL. And again, so this is the project. This is a data engineering lifecycle. But there are various agents or external factors that plays a very vital role into this data engineering lifecycle. So you have to maintain security, the data management. Okay, time to time you have to see which data needs to be retained, which data needs to be removed, okay, or made to take a backup of the old records. Maybe you even need to remove some data, delete some data, then various data operations on that data, then creating a data architecture, right? We need to plan the architecture, the structure, the flow of the project, how the flow will be maintained or how the flow will happen. Okay, then orchestration, automated execution of the project, different process of the projects at a particular time during the day. Then all the software engineering principles like version control, then automations, right? So all these things, then planning the execution of the project, okay, then performing CI/CD, continuous integration and continuous deployment. Okay, so all software engine and also programming, the main part, programming, writing the code for the project to take place. So all these are the undercurrents because they are the ones who will make this data engineering life cycle to work. Okay, so they are required uh, for the all these steps of ingestion and transformation serving to happen in a proper way. Okay, so this is the one aspect. So this is the basic data engineering life cycle. Okay, then apart from understanding the technical aspect, you have to also understand the business entities, right? Understanding business entities is of much importance because ultimately what you are doing, you are translating the business entities, the data generated to each and every business entity into the tables, into the what we can say tables and their attributes, right? So the whatever information is, this is where the information get generated, and the data is itself in the raw format. Then you put a proper give a schema, then structure it, okay, organize it, right? So how each and every business entity functions and what kind of data it produces, okay, and what are the each and every attribute of that data, it is it is of much importance to understand that. So unless and until you know which are the entities, what kind of data they're producing, what are attributes, how they function, which how is the interdependency between these business entities. So it would be very challenging to exactly create translate the things into the technical aspect. So you should be able to map the technical aspect to the business aspect, business entities, okay, so that you can understand the flow, you can understand the significance of each and every column, okay, and how it functions. Then only you can perform different operations on that, okay, data operations, manipulations, transformations, okay. So it's very much important when you are working with data engineering project. The first thing you should always do is to try to understand the business entities and map them with the data entities, okay, and the attributes. So understanding data is of each and every data point is of much importance. Then only you can uh, perform the actual execution. Okay. Then yes, now see all these business entities previously whatever we had. Okay, so we have converted them into the tables, a structure. Okay, so we have all these dimensions and they are participating together to form an order, that is sales, that is business transactions, right? So unless and until I know this flow, that how each and every table is or each and every entity is participating, okay, so if I don't understand that, then that will challenge to flow understand the flow of data. So it would become an issue when you are performing some kind of aggregations, some kind of transformations, okay, how the tables are linked or connected to each other. So now when I understand the business entities and their flow. I can easily understand the relation among each of the entity. And that's where the picture comes of entity relationship diagram, ER diagram. It shows interdependency. Okay. It shows how each and every entity is communicating with the another entity. Okay. So it is of much importance to understand this aspect so that you can transform those things into the technical aspect. Okay, technical things. Now the data engineering setup. Okay, so basic architecture. This is, I would say, a basic how an architecture is of data engineering. Different architectures may exist, but certain things in the architecture are very common. For example, you have a database, you have a source, and you have a destination, okay, where the data lands after performing all the operations. Okay, and from there, the data is being used by different external parties or the different external APIs or maybe some reporting tool. Okay, so here you have this architecture. Let's say there is one database. I'm just taking an example. It could be a database, it could be some API from where the data is generating. But here in this architecture, I have taken a basic example of database that is an OLTP source, online transaction processing. So this is a live database where the business, whatever the data is generated during the transactions in the business, is stored in this database. So it is very fast, it is quick, it's not massive, it is used for quick processing of the data. Okay, so in order to make it lightweight, it doesn't have a huge kind of memory, a massive. It's not that massive. Okay, so it's just a database, live database. The everyday transactions are being stored in this OLTP source. Okay, it doesn't maintain any kind of historical records. It's a live database. Every day, a fresh record or updated records get stored over here. Compared to that, at the destination, we have a data warehouse. It maintains all the historical records. It's not a live database. Okay, so whatever it has, it also maintains the historical records. Okay, the data warehouse is massive compared to database. It is not a live database, so it may contain historical records, previous past records. Okay, that helps, and moreover, it's an OLAP format. So already data, it's an online analytical processing. So data already is created into an analytical format. Maybe possible. Most of the aggregation part is done. Okay, in this data warehouse. So transactional data may not be available, but data in aggregated format or in analytical format, it's available for quick analysis, and that can be plugged to the reporting tool or any data visualization tool to quickly grab the what you can say insights or statistics of the data. Okay, so one is OLTP source and another data warehouse or OLAP source. So you can see all the data entities, business entities, customer, products, order items, stores, and inventory. It is available. It's there, and it's gets updated every now and then when the transaction happens. Then comes the staging area where we are going to stage the data from OLTP source in our system. Okay. So staging is a very important aspect so that it provides some kind of bulk, it some provides some kind of accumulated data on which the transformations can be performed. Because see the why it's important staging area, because whatever systems we are using, right? So those systems are very complex and designed for high payload of data. Okay, so but obvious, for that system to perform to its optimized level, okay, it needs, it has, we need to cater to that kind of level of data to that particular system. If the data is very small, it's a very negligible, what we can say, load. So using a massive scale of system is of no use, right? So it's ultimately going to not perform it to its optimized level. So better to provide a bulk or a good amount of load to that system, so that system can perform in an optimized format, right? So that's why we have a staging area. We accumulate all the data, and from there onwards, we put it to the transformation phase. Because if the accumulation is very low and using a high-end system to perform different kind of transformation, so it would be like providing too much resources for handful of data. Okay, and so it would be not an optimized way, performed in optimized fashion. Most of the data engineering project systems are designed for high payload of data and not for nominal data. So it's better to stage the data, accumulate the data at particular location. Once a good payload is available, then you can put that to the transformation phase. So already the data arriving will be in a good amount. But yes, before performing direct transformation, we stage it and then we uh, perform it, move it to the transformation phase. Or even at the staging location, we can perform some qualitative operations, or we can change the format of files that would be suitable for our system, right? So all that things we can do even at staging level. We can track the data for arrival when the data was available, right? So for that thing, the data staging area is important. Okay, then transformation, and then the loading part. Okay, then transformations, you perform all kind of aggregations, joining the tables, performing join operations, performing some aggregations, maybe some qualitative improvement of data, right? Maybe applying schema. Okay, so this is the transformation phase, and then comes the loading part. Final, once the qualitative data is available, you load the data into a data warehouse. Okay, so this is the project control and management. So you have this architecture, and you need following to in order to manage and control the project. You have data automation scripts, then logging and monitoring of the each and every operation, then the version control, then the orchestration, then maintaining the config files and performing some test, having some test case scenarios to perform some test cases on your project, right? So this is the basic foundational things which are required in the data engineering project. Okay, so I hope so you have got the idea. In upcoming videos, we'll dive more deeper and also apply these concepts into actual data engineering project. Thank you very much.